All right, guys, if you tried it already, here's a solution for you. Try A. If you chicken out, we're going to work it together here. All right, so how many zeros does this guy have to have? 4, right? For leading terms degree. Now that could be 4 positive reals, 4 negative reals, 4 imaginaries, or any combination of those, right? So we're going to make our little sign here. I remember last year I did real positive. No, I think I did it backwards. Positive reals, negative reals, or imaginary numbers. Remember, imaginary numbers have to come in sets of 2. We know that we have to have 4. So this guy could be 0, or this guy could be 2, or this guy could be 4, right? Because they come up in conjugates. Couldn't go any higher than that. Now we're going to use Descartes' rule of signs to tell us what our other options are for positive and negative. So for positive, how many times did we change signs? Positive, positive, whoops, negative, to whoops, positive, to whoops, negative. So possibly 3, which means negative has to be what? 1. Because 3 plus 1 would give me 4. And then if we have 2 imaginaries, this guy would drop down to 1, and 1, and 2. If we have 1, it looks to me like we have to have a negative 1. Let's find Descartes' rule of sign. If we put in negative x, remember it changes the signs for the even, or for the odds, but not the even. So that stays the same. Odd, we change signs. Even stays the same. Odd, we change the signs. Constants never change. Now how many times do we change signs? Just going from positive to negative, and then it stays negative. So we have to have 1 negative real. So this guy is out. And so we either have 3 reals, 3 positive, 1 negative, or 1 positive, 1 negative, and 2 imaginaries. All right, so let's take a graph. Remember I said in the last video, you'll get something that looks like this. I don't have it on here, but you'll get something that looks like that on your test. It'll get you in the ballpark, but it's not going to tell you for sure. So I've already actually graphed it on Desmos, but I guess it went away. Actually, I think it's here. Maybe, no, here. Excellent. Desmos has gone away. Let me bring it back. Sorry about that. Actually had it graphed out and everything. All right, we're going to try to graph this guy. So you'll see kind of what you'll see on your quiz on Friday. So x to the 4th plus x cubed minus 26x squared plus 4x minus 120. All right, so this is kind of what you'll see. Unfortunately, this is exactly what they are, but you'll see maybe something more like, something more like this. So it looks like we have 1 positive and 1 negative, right? So I think we're going to end up with this scenario here where we've got 1 positive, 1 negative, 2 imaginary. Looking at our graph, it looks like we're close to, say, -6 and +5. So I'm going to test those first. Putting in -6, coefficients are 1, -1, sorry. Don't go off with the negative, this here is go off with positive. This is the one that we're getting our coefficients from. -26 for -120. Drop down the 1 times -6 is -6. 1 minus 6 is -5. Times -6 is 30. Minus 26 is 4. Times -6 is -24. Plus 4 is -20. Times -6 is +120. So that indeed is one of our zeros. The other one we said we thought was at 5. So I'm going to plug it into this guy down here. 1, -5, 4, -20. Bring down the 1 times 5 is 5, minus 5 is 0, times anything is still 0. Bring down the 4 times 5 is 20, and that's a 0. And this is going to be x squared plus 4. This is a non-factorable quadratic, so we're already ready to do part A. Part A says list these guys as linear factors, so x plus 6 times x minus 5 times the non-factorable linear, or non-factorable quadratic, irreducible quadratic, I think is how I said it. So x squared plus 4. Now B wants us to put it all into all linear functions, or all linear factors, so we actually want to solve this guy. The x squared is equal to negative 4. X then would be plus or minus the square root of negative 4, which is plus or minus 2i. And so I have f of x is equal to x plus 6, x minus 5, x minus 2i, x plus 2i. Last part, they want us to find the zeros. Well, our zeros are going to be what makes these guys zero. So negative 6, 5, 2i, negative 2i. All right, that's it for B. Let me go ahead and show you this. Or sorry, for A. There's B. Go ahead and pause your video. See if you can find it. And by that, see if you can find your linear factors with your irreducible, all linear factors, and then all your zeros. Come back when you think you have it. All right, we are back with B. Hopefully you said your possible factors for 108 or 1. Oh, we never did it for here. It's always good practice. 2, 3, 4 goes in there, 6 goes in there, 9 goes in there, 12 times 18. And then we can come back out. So 9 times 27. Okay, that's right. And then 36, 54, 108. All right, how many times does it change signs? Positive to negative is 1, and then back to positive is 2. So for my positive reals, we have a possibility of 2. What about negative x? For our negative reals. Odd numbers change signs, even stay the same. Odd change signs, even stays the same. Odd change signs. Constants always stay the same. So now we're going negative, negative, positive, back to negative, back to positive, stays positive. So 3. So negative reals could have 3, and then we've got imaginaries. Now how many does each have to have in the columns? Remember, that's your highest degree. So 2, 3, that's 5. If that's the case, then we have 0 imaginaries. Or I could have 0 positives, 3 negatives, and 2 imaginaries. Or I could have 2 positive, 2 imaginaries, and what would that leave me with here? Just 1 real negative. Any other options? I don't think so. I think that's all that we can come up with. Let's take a look at the graph and see what we think. So looking at our graph in Desmos, it does not like me today. I don't know why it doesn't like me. Doesn't want me going fast for some reason. Negative, negative. All right, we've got x to not the 4th, but to the 5th, minus 2x to the 4th, minus 2x to the 3rd, minus 6x squared, minus 99x plus 108. All right, what does it look like to you there? To me, it looks like I've got 3 real zeros, 1's negative, and 2 is positive. So I'm going to come back over here, and I think we've got 1 negative, 2 positive. So I think this is our scenario that we got here. Taking a look at that graph, get too excited because it doesn't tell you exactly where they are. That looks like maybe negative 3, 1, and 4, possibly. So we're going to try negative 3, 1, and 4. I'm probably, just so you know, going to give you some that maybe have fractions to make it a little harder or challenging. Depends on my mood, I suppose, when I'm writing it. So here's negative 3. What are my coefficients here? 1, negative 2, negative 6, negative 99, 108. Bring down the 1, negative 3, negative 2 is negative 5, times negative 3 is 15, minus 2 is 13, times negative 3 is negative 39, minus 6 is negative 45, times 3 would be 135, if I'm not mistaken. Minus 99 would be 36, times 3 is good, negative 108. So that one worked well. We said 1 possibly, so let's try 1. Bring down the 1 times 1 is 1. Negative 5 plus 1 is negative 4. Times 1 is negative 4. 13 minus 4 is 9 times negative 1. Negative 54 times 1. Oh, that did not look good. Where did I go wrong? Oh, 9 times 1, Miss Harris says positive 9. So this becomes not that direction, but this direction. Negative 36 times 1 is negative 36, and we have 0. And then our last one we said we thought was 4. Trying that guy out, we got 1 times 4 is 4. Minus 4 is 0 times 4 is 0. Plus 9 times 4 is 36. And there we go. Now we've got all of the factors that we need to write for A. So A is f of x is x minus a minus 3. So x plus 3. X minus 1. X minus 4. And then my irreducible quadratic factors is going to be x squared plus 9. Good? B. What do I need to do to find B? It wants it all in linear factors. We've got the 3 linear factors. Now we need to take this x squared plus 9 and find out what its linear factors are. So moving this over, they're going to be imaginary, but they're still linear. And the square root of both sides was the square root of negative 9, plus or minus 3i. So x minus 3i, x plus 3i. And there's our 5 factors. And then what are the zeros? Negative 3, 1, 4, positive 3i, and negative 3i. All right, that is it for today. I'm going to try to go back and remake some of those 2.4.2 videos that were kind of wonky. Some of you are struggling with that today in class. You guys have a great night. See you tomorrow.